Hi, kids! This is going to be a little video about some kinematic basics, some basic terminology and stuff like that. You should already know the difference between distance and displacement. Distance is just how far you travel. Remember, both are going to be measured in meters. Where displacement is how far you end up from your starting point, plus the direction that you went. So if you remember from some terminology, distance would be considered a scalar. Displacement would be considered a vector because you need to have that direction piece. Remember, a lot of times the direction might be east, south, north, west, that type of thing. But sometimes the direction might just be, hey, it's in the positive direction, it's in the negative direction. It's moving forward. It's moving backwards. That would also be direction. So anyway, distance versus displacement. All right. So today we're going to talk about some other stuff along these same lines. So let's talk about speed versus velocity. Now, to average Joe Schmo, the average Joe Schmo might think that speed and velocity are the same thing. Well, you are no longer an average Joe Schmo. You are now a physics guru, super smart person. But speed is just how fast you travel. Or if you like, speed is the rate that your distance changes, where velocity is going to be your speed plus direction. Okay? Speed is a scalar. Velocity is going to be a vector because it includes direction. Just like we talked about before, that direction could be positive, it could be negative, but again, you'd have to know what the positive direction or the negative direction means. It could be just east, west, that type of thing. But scalar and a vector. Remember, if you think about units, this is going to be meters per second. This would also be meters per second. Those are most of the time the units that we're going to use. Or if you like, sometimes it might be miles per hour. That would be something like that. Just so you remember to go from meters per second to miles per hour, it is roughly, let me just say roughly, so it is roughly double it. So that if you have 5 meters per second, that is going to be roughly 10 miles per hour. Why is that important? Well, if you get a person and you're doing the math and you get a problem and it says, hey, you have a person who is going 20 meters per second. My hope is, well, unless that person is Superman, you would go, yeah, that doesn't make sense, because that means that person is going 40 miles an hour. Where if you have a person going 20 meters per second, 20 miles per hour, that is doable. That's a person running super fast. World-class sprinters can run in the 20 miles per hour range, that stuff. Okay? But to go from meters per second to miles per hour, roughly double. Okay? Now remember, you are actually taking additional notes, over things other than just what's written down here, right? Because you're a good student. Yes, you should be taking some additional notes. Okay, so just remember scalar, vector, direction. So if you had something that said, hey, you are going plus 5 meters per second, as long as you knew what the plus means, then if the plus means to the right, that means that's a velocity because you are moving 5 meters per second to the right. If you had 60 miles per hour, that would be a speed. Why? Because it's just telling you how fast you're going. Your speedometer in your car tells you your speed, not the velocity, unless it has a compass attached to it, because most of the time it doesn't tell you direction. Okay? All right. So that is speed versus velocity. Now, when I was growing up, we always traveled to Colorado, to Breckenridge, Colorado. And from here to Breckenridge, Colorado is roughly 1,200 miles. And when I was driving up, it would literally take a whole day. So imagine, I have 3 brothers. Imagine being stuffed in a car with your 3 brothers and, traveling for 20 hours, 24 hours straight. It was fantastic. I'm not scarred at all. From here to Colorado in 20 hours. Okay, so here's what I'd like you to do, is to figure out the speed that for our trip to Colorado. So yeah, go ahead. You can pause it. Figure it out. Figure it out. Okay, I'm assuming you come back. All right, we'll go back. Hopefully you said the speed was 60 miles per hour. And then my next question is, well, how did you do that? And my hope is you said, well, to find the speed, I did distance divided by time. Yes. So in fact, speed. Now, the script V is how we typically show speed, where like just a V is what we're going to use typically for velocity. But if you end up using a V for both of them, that's fine. But usually it's a script V for speed and a regular V for velocity. But so hopefully you said, well, I just did this. So I did speed equals distance over time. So it's 1,200 miles divided by 20 hours, and lo and behold, you got 60 miles per hour. Now, 60 miles per hour, that would be a speed. Why? Because I'm not telling you the direction. Now, if you were to say 60 miles per hour west, hey, that's now a velocity. Or if you were to call the east direction positive, then it would be negative 60 miles per hour. The negative is telling you direction, okay? But let's say we're going this. So my next question is, does that mean when we're traveling to Colorado that every single time you look at that down the speedometer, it reads 60 miles per hour? And the answer is no, of course not. If my older brother was driving, it would read like 84 miles per hour. If, my dad was driving, it would read like 69 miles per hour, because it's okay to speed just a smidge, but not okay to speed a lot. And if my mom was driving, it would read 0 because we pulled over so she can go pee. So if you have, anyway, so 60 miles per hour. Well, then what is the 60 miles per hour? And hopefully you're okay with this, that actually is what is called the average speed. Now, in math class, to show average, and we're going to do the same thing, you put a little bar over it to show average. So, average speed is equal to, we'll say this, which is really distance divided by time. Now, if you look on the formula sheet, it's not there, okay? Why? Because the College Board expects you to know that average speed equals distance over time, okay? Where average velocity, so this would be average speed, average velocity is going to be displacement over time. So this would be average velocity. This would be displacement. And if we're talking about horizontal displacement, just like in your math class, X is going to be for horizontal, okay? That's typically the symbol we're going to use for displacement. It's going to be X. So if you're saying X over T. So let's say you're running around the track outside. Well, if you run one time around the track, the distance you go is 400 meters. So if you did 400 meters and divided by whatever time, that would tell you your average speed. Well, the displacement, if you start and stop at the same spot, would be 0. So that would be your average velocity would be 0. Okay? But so just keep that in mind. So that is the difference between average. So let's say, my brother is driving and a police officer pulls him over and he says, excuse me, son, did you know how fast you're going? And my brother's like, well, I don't know. And the officer said, well, you're going 89 miles an hour or 84 miles per hour. And this would not work. It wouldn't work for my brother to say, well, but officer, I wasn't going to drive that long. Or, but officer, later on I was going to go really slow and it's going to all average out. Because the police officer doesn't care about your average speed. The police officer cares about your instantaneous speed, how fast you're going right now. Now, I'm going to say speed, but it could be velocity. Velocity would just be how fast you're going right now plus the direction you're going. But instantaneous speed is how fast you are going right now. Okay, that's what your speedometer tells you. Your speedometer tells you your instantaneous speed. Now, most of the time, I'll talk about velocities just because that's what's going to be on your equation sheet. We're going to use a VO for your initial speed. That would be an instantaneous speed. And then most of the time where the V bar is average, but if you just say V, that most of the time is going to be what we're going to use for your final, well, I guess I should say speed or velocity. And then I'll do the same thing. Where then V would just be your final velocity, okay? Sometimes it's also, they'll say like V1 and V2, so it's like, hey, this is your velocity at one point and this is your velocity at another point. But your instantaneous speed is really what the police officer cares about because he wants to know how fast are you going right at that instant. Now, speaking of driving, okay, last little piece that we need to talk about. Speaking of driving, I have this really super duper sweet car. My sweet car goes from 0 to 60 miles per hour. Yeah, you heard me right. My car goes from 0 to 60 miles per hour. Aren't you like super duper impressed? I mean, it goes from 0 to 60. Yeah, what do you want to know? Oh, right, yeah. You want to know how much time does it take? Does it take 10 seconds? That's pretty impressive then. Does it take 10 minutes? That's not so impressive. My car is closer to the 10-minute thing than the 10-second piece. But, so yes, when we are talking about the rate that your velocity changes, that is what is called acceleration. Now, a couple things that is important here. Okay, so we are talking about velocity. So acceleration is the rate velocity changes. So anytime you're talking about rate of something, that's always going to be in a certain amount of time. The symbol for acceleration, this, I know this can be hard to believe, is an A. I know, A for acceleration. And the acceleration is going to be the change in velocity divided by the time that it takes. So the change in velocity over the time. So in this case, it would be, plus, because it'd be final minus initial. So it'd be plus 60 miles per hour divided by however much time. So if we were to do that, so let's say if my change in velocity was 60 miles per hour, and let's say the time was, 12 seconds, then you would end up with 5 miles per hour per second. 5 miles per hour per second. Huh? So what does that mean? Oh, that means that the rate that my car is gaining speed is 5 miles per hour every single second. So if you were sitting at a stoplight and you accelerated at a rate of 5 miles per hour per second, as soon as the light turns green, you hit the gas. After 1 second, how fast are you going? That's right, 5 miles per hour. After 2 seconds, how fast are you going? That's right, 10 miles per hour. And then 15 miles per hour after 3 seconds, and 20 miles per hour after 4 seconds. So every single second, your velocity changes. In this case, it would gain 5 miles per hour per second. Okay? Now, most of the time, we're not going to be using miles per hour in here. So if we wanted to do this in terms of what we're going to be using, which is meters per second, remember, to go from meters per second to miles per hour, you roughly double it. So this is going to be roughly 30 meters per second. I'm going to, just to make the math easier, we're going to say that it was actually 36 meters per second, because that makes the math easier. And then I have here, so I end up with 3 meters per second per second. 3 meters per second per second. 3 meters per, yes. That means the velocity is changing at a rate of 3 meters per second per second. So again, if you're starting at a stoplight, you would be 0, and then after 1 second, you're going 3 meters per second. After 2 seconds, you're going 6 meters per second. After 3 seconds, you're going 9 meters per second, and so on, okay? But that's what this means. So I would like you to pause the video. Yes, I'm asking you to pause the video and to write a sentence, what this means. What does an acceleration of 3 meters per second, what does that actually mean? So pause it, write it down, put it in your notes, because you're supposed to be writing more stuff than I'm writing, and then I'll come back. Okay, did you pause it? Did you write it? Good. Okay, but hopefully you said something like, it means that your velocity is changing 3 meters per second every single second. Be careful. Do not say you're going 3 meters every single second. That's something completely, totally, utterly different, okay? That means that you would be traveling the same distance. In this case, you're not traveling the same distance, okay? This is are going faster and faster. Last, okay, I did say acceleration is defined as the rate velocity changes. So, to change your velocity, there are 3 ways. There are 3 ways to accelerate, okay, or 3 ways to change your velocity. So I would like you to pause the video and come up with, what are those 3 ways to change your velocity? All right, pause the video. Did you pause it? Did you think about it? Okay, all right, so let's come up with our 3 ways. Now, the first way should be easy, because this is just how average Joe Schmo thinks of acceleration. Average Joe Schmo thinks accelerate means you speed up. So one way to accelerate, for example, if you're in your car, would be to speed up. Okay? So that this would be, hey, I'm moving forward and I'm accelerating forward. I'm getting faster. Okay? I'm speeding up. Okay? Another way to accelerate, okay, well, how else would you change velocity? Well, you could slow down, okay? And you might think, no, that's deceleration. And I would tell you, no, that's acceleration. It just means that you are accelerating in the opposite direction that you're moving. So with the first one, if your V was going this way, then your A is also going that way. So I am moving in the same direction that I'm accelerating, so I'm going to speed up, okay? So a different way to accelerate is to slow down. This would be in your car, hit the gas. This would be in your car, hit the brake, okay? This would be, hey, if I'm moving this way, but I am accelerating that way. Now, again, we're talking vectors, and sometimes we do vectors with east-west. Sometimes you do it with positive-negative. Well, if I was calling to the right positive, this would be my velocity is positive and my acceleration is positive. My velocity is positive, now my acceleration is negative. But I want to caution you, negative acceleration doesn't necessarily mean you're slowing down. Okay? That, again, you got to understand, it just means negative acceleration means your velocity is changing in the negative direction. Well, for example, if I was moving this way, if I called this positive, this way would be negative, and I was accelerating this way, hey, guess what? I'm speeding up. How could that happen? Well, if you're in your car, you put it in reverse, and then you hit the gas. You speed up going backwards. Okay, so I don't want you to think, so just so you know, this would be like, if we're calling to the right positive, this would be negative velocity and negative acceleration. So make sure that that truly makes sense to you. This is not about memorizing stuff. It is about understanding. Okay? The last way to accelerate, and this is the one that is truly going to blow your mind, remember, velocity is speed plus direction. So how do you change velocity? Well, you could speed up. How do you change velocity? You could slow down. How else could you change velocity? You could change direction. So the third way to accelerate is to change direction. And yes, this one is weird. This is the one where nobody, unless you're a physics person, understands this. So just think, I know when I was growing up and I was learning to drive, I had a parent who was kind of like this. And maybe you guys had a parent that was kind of like this too, or I have a parent that's kind of like this. Where when I was driving, all of a sudden if I'm driving along, I'd be driving along, doo, 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 and then all of a sudden my mom would go, and I'd be like, what? And if you have a mom that's, kind of like that, there's a little bit up tense when you're driving. Here's what I want you to do next time. You're going to say, hey, Mom, check it out. I'm going to really accelerate around the corner. And then, you just take the corner like you normally would. And your mom's going to be like, well, what are you talking about? And you can say, well, Mom, acceleration is defined as the rate that velocity changes. And velocity is really speed plus direction. So even though I wasn't changing my speed when I went around that corner, I was changing my direction. So therefore, I was accelerating. And I promise you, for at least a little while, she'll leave you alone. Okay? But if you think about it, with this one, hey, if my velocity is pointing to the right and I'm accelerating in the same direction or this way, that causes it to speed up, where if it's opposite, it's going to cause it to slow down. Well, guess what? In this case, this would be where I'm going this way and I'm accelerating that way. And you might think, well, when would that ever happen? Well, throw a ball horizontally. It's going to move this way, and the instant you throw it, it's going to accelerate that way. Okay? It's going to change its direction. Okay? So 3 ways to accelerate: change direction, speed up, slow down, change direction. And then the last thing I should just mention is going back to my units really fast. If you have meters per second, that is the same thing as doing this. Okay? Dividing by seconds is the same thing as multiplying by the reciprocal, and you end up with meters per second squared. So a lot of times the units for acceleration are going to be meters per second squared. Okay, so just make sure you understand meters per second squared, same thing as meters per second, not the same thing as meters per second. Okay, all right, bye kids.